Welcome to our lecture online. Today we're going to talk about another topic in algebra called the Gauss-Jordan method of elimination, and we're going to apply it to three equations and three unknowns. In other words, a set of linear equations with three variables. Right? The way to do that is to take the coefficients of the equation and the numbers on the right and place those into what we call an augmented matrix format. So here you get coefficients 3, -2, 8, -2, 2, 1, 1, 2, -3. So those are the coefficients of the variables of your three equations. And then the numbers to the right equal sign, you place them over here. Then the objective is to change this, using of course the correct rules, into a format that makes it look like that. Ones across the diagonal, zeros everywhere else for the coefficients of x, y, and z. And then of course to the right you'll have the values for x, y, and z to the solution that will be the solution to these three equations. All right, how to do that? Well, we can add any two rows together. We can multiply any row by number and add it to a third row and so forth. So we're going to take this number right here and try to turn that into 1 first. So we want to start with the diagonal, make that into a 1, everything else 0, make this into 1, everything else 0, make this into 1, everything else 0, and then you have your solution. So how do you turn this into a 1? Well, notice that if we add row 1 and row 2 together and add it in the place of, and put it in the place of row 1, we'll have a 1 there. So I'm going to take row 1 and replace it by the sum of row 1 and row 2. So this means take row 1 and replace it by the sum of those two. If we do that, we get the following result. -2 plus 3, that gives us a 1. 2 plus a -2 is 0. 1 plus 8 is a 9. And 3 plus 9 is a 12. Leaving everything else the same, we have a 9 minus 2, 2, 1, 3. We have a 1, 2, -3, 8. I could have also interchanged row 1 and row 3, because if I put this row over there and put this row over there, I would have had a 1 there as well. So either rule would have worked. Next, we want to get rid of this one and this one. And the way to do that is to take row 2, so row 2, and replace it by the negative of this number, multiply times the first row, and add it to this row. So I'm take the negative of that number, that's 2 times row 1, and add it to row 2. And to get rid of this 1 here, we take the negative of this number, so row 3 is replaced by the negative of this number, which is -1, times the row with the 1 in it, and adding it to row 3. Okay, so we're going to do those two steps together. So then I end up with the following result. If I take 2 times row 1, that's 2 times 1, and add it to -2, I get 0. So, or, by the way, let me put row 1 down first, because I'm not going to change row 1 at all. I'm only changing row 2 and row 3. So 2 times 1 added to this gives me 0. 2 times 0 added to 2 gives me 2. 2 times 9, 18, added to 1 gives me 19. 2 times 12, 24, plus 3 gives me 27. And for the third row, I'm going to take -1 times this added to row 3. So -1 times this added to that gives me 0. -1 times this added to 2 gives me 2. -1 times 9 is -9. Added to -3 is -12. And -1 times 12 is -12. Added to 8 gives me -4. So now I've gotten a 0 here and a 0 there. Next, I'm going to attack this one. I want to turn that into a 1. The way to do that would be to take the whole row and simply divide it by 2. So I'm going to do that. So take row 2 and replace it by 1/2 of row 2. So what I'm saying here is simply divide row 2 by 2. If I do that, I get the following matrix. Okay, what is not changing? Of course, row 1 and row 3 are not changing. So I get a 0, a 1, a 0, a 9, and a 12. And I have a 0, a 2, a -12, and a -4. So row 1 and row 3 are not changing. Row 2, I'm simply taking half of what I had there before. So this becomes 0, 1, 19 divided by 2, and 27 divided by 2. All right, now the next step is to turn this and this into 0. Since that's already 0, I only have to worry about this one right here. So I'm going to take row 3 and replace it by the negative of this number times the row with the 1 in it, which would now be row 2, and adding it to row 3. And by doing that, this should go to 0. Let's see what happens. So I'm not changing row 1 at all, so that's still 1, 0, 9, and 12. I'm not changing row 2, so that's 0, 1, 19 over 2, and 27 over 2. But I'm changing row 3. I'm taking negative 2 times this and adding it to this. So negative 2 times 1 adding to 2 gives me 0. This is, of course, still 0. That's 0. Negative 2 times this gives me minus 19. Added to minus 12, that gives me minus 31. Negative 2 times this gives me minus 27. Added to negative 4 gives me minus 31. All right, I'm getting closer now. I already have the first 2 columns looking the way I want to. Now we go to the third column. I start with taking this number right here, and I want to turn that into a 1. To do that, I have to divide this by a negative 31. So row 3 becomes row 3 divided by negative 31. Okay, if I do that, the other 2 rows stay the same. So this becomes a 1, a 0, a 9, and a 12. 0, 1, 19 over 2, and 27 over 2. Next, I'm going to turn this one into something that will give me a 1 there. So that's 0, 0. This divided by negative 31 is, of course, a 1. This divided by negative 31 is a 1. Okay, very good. Next, I want to take this and turn those into zeros. To turn the first one into 0, R1, I'm going to replace it by the negative of this number, minus 9, times the row with the 1 in it, which is R3. And maybe I should make this a solid line so it's a little better to see. And then adding it to row 1. Take row 2. I take the negative of this number, so minus 19 over 2, multiplied times row 3, and adding it to row 2. By doing that, those 2 numbers should go to 0. So let's see what happens. Coming over here. What is not changing here? I'm not changing row 3. Row 3 stays the same, so 0, 0, 1, and 1, like so. So for row 1, I take minus 9 times this. So minus 9 times 1 is minus 9. Added to 9, I get 0. And of course, I still have the 1 and the 0 there. That doesn't change. So minus 9 times 1, adding it to 12, that gives me 3. Okay. Row 2, I take minus 19 over 2 times this, adding to that, that makes 0. So I get 0, 1, 0. And minus 19 over 2 times this, added to 27 over 2. So minus 19 added 27, that gives me plus 8 over 2. And 8 over 2 is a 4. And I'm done. I have exactly the format I want here, which means 1 times x is 3, so x equals 3. 1 times y is 4, so that means y equals 4. And 1 times z is 1, so z equals 1. And that is the solution to my set of linear equations. And that's how you use the Gauss-Jordan method of elimination. Now,